Okay, so remember to draw your covalent bonds. What we can do is to move the electron one each from each atom into the overlapping part and then count at the end of it to make sure they have 8. If they have 8, means your drawing is correct. Okay, but there is an easier way to draw the covalent compounds, and if you use this method, any formulas that they give you, any difficult molecules that they give you, I am sure you will be able to draw. Okay, so in this example over here, we are going to look at the molecule H2O. Okay, so step by step, what we must do first is we must find out how many valence electrons do each element have. In this case, your H2O, your hydrogen have 1 outer electron or 1 valence electron. Your oxygen have 6 valence electron. Remember, oxygen is in group 6. Group 6 means 6 outer electron. Then find out how many bonds can each element form. How do we know how many bonds can they form? We take the octet minus the valence, or we take the full configuration or the noble gas minus the valence electron. So your hydrogen, the noble gas configuration, because there's only 1 electron, the noble gas configuration have to be 2. So in this case, for hydrogen, you take 2 minus 1. Your hydrogen can form 1 bond. Okay, because I take the 2, this one is the noble gas configuration minus the valence. Okay, 2 minus 1. Yeah, and then oxygen, same thing, take the noble gas configuration, have to be 8 for oxygen minus the valence 6. Then you can form 2 bonds. So my oxygen can form 2 bonds. Okay, so after you determine how many bonds can each element form, what do? We draw lines out from the element. Okay, one line is 2 electrons. Okay, so draw the lines out from each element. Your hydrogen can form 1 bond. So your hydrogen can form a bond like that. Or it can form like that. Or it can form like that. Or it can form like that. Anyway, anywhere that your bond is, whether is it on the right, on the left, vertical, horizontal, etc. Anywhere where your bond is, right, it doesn't matter because the atom itself is 3-dimensional. So if you rotate it, it can be on the left, can be on the right, can be diagonal and all that. Okay, so in other words, your hydrogen can form 1 bond. There's only one possibility, which is this one. Okay, then my oxygen can form 2 bonds. Where were we just now, right? Your oxygen can form 2 bonds over here. Correct? I take the 8 minus 6. 8 is the full minus 6 is the valence. So your oxygen can form 2 bonds. 2 bonds means what? There is 2 lines coming out. So from oxygen, I can have 2 lines coming out here. This one will be the same as this one, or this one, or this one. Okay, same thing because they are all 3-dimensional. So my oxygen have 2 lines coming out. One of the option could be this, the other option could be this. Okay, this one is the same as this, is the same as this. Okay, again because they are 3-dimensional. Okay, so my oxygen, the orientation for your bonds is going to be this one or this one. Okay, so now I have A, I have B, and then I have C. And then I am trying to link hydrogen and oxygen together so that they can form covalent. Okay, my hydrogen can only form 1 line. So this one you should know immediately. Your oxygen cannot be this. Because this one I need 2 lines to connect. Here I only got 1 line. Okay, so your oxygen can never be this. Okay, cannot be this. This one is already crossed out. Okay. So in other words, the only one I can make it work is my A with C. Yeah. So how can you connect A and C, right? So that they can actually form H2O. So my oxygen is going to be here, right? And then my hydrogen will connect to this side because one of the line is here. And then if I rotate your hydrogen, this hydrogen is also equals to this. Okay. So if I use this one to connect over here, then you can have your H2O. So your water will look like this, okay? Your water compound will look like this, and then you convert this to your dot and cross, okay? So hydrogen atoms, right? what we are going to do is to convert it to your dot and cross. Okay, so over here, let me try to draw it over here. Yeah, so what does it mean? Oxygen is going to be in the middle, okay, and then your hydrogen is going to be over here, right? So recall one line, how many electrons? This is a single covalent bond. Single covalent bond, there must be 2 electrons inside. So here, okay, the electron come from each atom, so my cross will come from the hydrogen. The dot that I'm trying to draw here comes from the oxygen. The cross will come from the hydrogen. The dot will come from the oxygen. Okay, and then actually there is one last step over here. One last step, which is to make sure, okay, the element have all their electrons. Okay, make sure the element have all their electrons, and then all of them are in the noble gas configuration. Okay, so let's look over here. Okay, so same thing. Now you count your oxygen. Okay, if my cross belongs to hydrogen, my dot belongs to oxygen. Okay, so my oxygen only got 1 electron, 2 electron, but oxygen outer electron is 6. So there should be 4 more electrons that's outside here. Okay, now your oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is in the noble gas configuration. Okay, and then your hydrogen, right? Now it has 1 cross and a circle, a dot, right? So it has 2 electrons. Likewise, this hydrogen second atom, it has 1, 2. It has 2 electrons. So 288, it has achieved the duplex configuration, which is the noble gas configuration. So only in this particular setup, everybody is happy. Okay, so after you draw this structure, you just have to convert it to dot and cross, right? One line, put the 2 electrons inside. Okay, one must be dot, one must be cross. Okay, so this one over here is exactly the same as what I just drew, and then this is your final answer. Okay, so this picture over here, I only draw the valence. Yeah, I never draw the full. If your school asks you to draw the full, then you put in the inner electrons, which is this one. Okay, because your oxygen has 2 inner electrons. Okay, so this one is your dot and cross diagram over here. This is the dot and cross. Sometimes your school may ask you to draw the structure diagram. So structure diagram will look like this. Okay, this one is your structure diagram.